Agora vamos passar a palavra ao professor Richard Marciano. O professor Richard Marciano é professor na Faculdade de Estudos da Informação, High School da Universidade de Maryland. Ele é um membro do corpo docente afiliado do Instituto de Pesquisa de Sistemas, na Escola de Engenharia do Departamento de Ciência da Computação. Antes disso, ele foi professor na Escola de Formação em Ciência da Biblioteca da Universidade da Carolina do Norte, em Chapel Hill, por 5 anos. Ele também foi um cientista pesquisador no Centro de Supercomputadores de San Diego, na Universidade da Califórnia, San Diego, por 13 anos. Seus interesses de pesquisa se concentram em ciência arquivística computacional, CAS, curadoria digital, preservação digital, arquivos sustentáveis, cyberinfraestrutura e Big Data. Ele também recebeu o prêmio Emmett Leary de 2017 por trabalho excepcional e sustentado em registros digitais e gerenciamento de informações. Ele é formado em engenharia aviônica e engenharia elétrica, tem mestrado e doutorado em ciência da computação pela Universidade de Iowa e realizou um pós-doutorado em geografia computacional. So, thank you, Dr. Marciano. Now you can speak. Thank you.
Can you hear me?
Yeah.
Okay. Obrigado. Boa noite. Let me see if I can share my screen. So you're going to have to tell me where to do that. Share screen.
Not yet.
Screen sharing. Hold on. Entire screen. Okay, hopefully. Okay, how's this?
Not yet. Yeah, it's coming. Yeah. We can see.
Okay.
Yeah, we can see.
Okay, wonderful. Thank you very much for inviting me.
Sorry. Can I present Dr. Ginana?
Yes, thank you. That would be great.
Oh, okay. So it's better to present now than later. Então, dando continuidade, eu gostaria de apresentar o Dr. Rajesh Kumar Ginanasekaram, que é um acadêmico praticante na interseção entre academia e indústria, com uma posição única, com mais de 18 anos de experiência profissional em TI e um sólido histórico acadêmico, culminando em um doutorado em ciência da informação em 2025. Sua jornada acadêmica tem consistentemente mesclado bolsa de estudos rigorosos com aplicações reais de inteligência artificial. Ele traz uma rara combinação de liderança empresarial na implantação de inteligência artificial e excelência em pesquisa em ciência arquivística computacional e inteligência artificial generativa. Ele auxiliará o professor Richard Marciano em sua apresentação. Então, muito obrigado. Now, Richard, you can talk. Thank you.
Obrigado. Thank you very much for inviting me to join your symposium. It's a pleasure and honor to be part of these conversations and to listen to my amazing colleagues who are doing all this innovative work. The title of our presentation is quite broad. It's looking at the impact of disruptive technologies on archives and records management. So I'm going to, I think I have like not quite a dozen slides, and what I'm going to do is share the podium with my colleague, Dr. Rajesh Gnanasekaran. He actually just got his PhD in June. We worked together on a number of projects, and I thought it would be interesting for me to provide some broad context on the kinds of disruptive technology, archival spaces we operate on, and then for Rajesh to jump in and go in depth on one of the many collaborations and projects we've developed. So this way you get kind of some general perspective, and then a demonstration of some very specific results and outcomes. So hopefully the combination will be useful for the viewers. Okay, so I'm going to jump right in and talk about an initiative we have been developing for the last decade. Actually started in 2015. And so we have been exploring what we called CAS or CAS, which is computational archival science. So the short explanation for that is exploring computational treatments of archival and cultural content. So I'm going to give you a few resources, definitions, and a little bit of context. Should this initiative be of interest to you, that we have a Google group email you can join. There's also kind of a seminal paper that we wrote in 2016 that only came out in 2018. And it's with a number of colleagues, including Victoria Lemieux, who spoke yesterday. And the paper, there's a reference there. If the slides are shared, you can take a look at it. Was called Archival Records and Training in the Age of Big Data. So we have a long definition of, kind of involved definition of computational archival science. I won't read it, but I'll summarize it. So the essence of that is sort of interdisciplinary and even transdisciplinary. That's what the paper discusses. Collaborations centered around archival information and computational science. And it's an initiative that is focused on the application of computational methods and resources to large-scale records and archives processing. The goal is to revisit, not unlike inter pares versions and the latest instantiation, is to revisit traditional archival processing steps, such as acquisition, appraisal, arrangement, access, etc., in the context of disruptive technology. So it's not just AI, it's not just the latest flavors, dialects of AI, Gen AI, large language models, all these things. It's that and what came before and whatever will come next. So it tries not to succumb to the current trends, but to take kind of a longer view of what we're dealing with. So there is a CAS portal. If you go to the ai-collaboratory.net/CAS, you'll see a lot more information about this initiative. There's a paper that Victoria Lemieux and I put out just a few months ago, which I think would be very useful if you want to get a kind of a bird's eye view of these developments, called Teaching Computational Archival Science. And it is an overview of about 10 years worth of collaborations, projects, curricula development for master's students, professional training programs, even working with undergrads. So it has a rather long list of all kinds of projects and initiatives and experimentation, both at UBC under the leadership of Victoria Lemieux, and at the University of Maryland with many of my colleagues who have participated in that. So we've actually had over 50 workshops. There are several hundred papers on these topics, and we've been running a computational archival science workshop as part of the IEEE Big Data conference for the last 10 years. So I have two links on this slide. I'm going to switch over and I'll just show you if you care to go there. So this was our conference last year. It was in person in Washington, D.C. And if you were to go there, you'll see a one-day workshop. You'll see kind of these topics: trends in computational archival science, a session with a bunch of paper with 5 talks on exploring and using archives, another session on artificial intelligence for archival functions, another session on computer vision and multimedia video processing, several sessions on ethical considerations of working with computational methods, and then a big focus that's been there since day one, it's archival education and training. If you go to that particular link, you'll have presentations, slides, videos, papers, and there are about 150 of these kinds of papers and presentations. So a quick plug. There's still time if any of you are interested. We'll have kind of our anniversary 10th CAS workshop in December. This one will be entirely online on Zoom, so no travel needed. It will be open to everyone. If you're interested in participating in this, just contact me, and as we get a little closer. And if you'd like to contribute some of your work, it's not too late. There's a early November deadline to submit a short paper or long paper for potential consideration and inclusion in the next workshop. So you have some information here. Let me put that back in the background. So those are the two links I just showed you. But if you go to the portal, you'll see links to hundreds of papers and a lot of the content we've been developing. Okay, just a little more background, if you can bear with me, and then we'll jump into the fun stuff, which is actual case studies and examples of how we approach the intersection of computational methods and archival studies. So in 2020, just before COVID, we also launched what we call a collaboratory that we named Advanced Information Collaboratory. So you can go to that link if you'd like a little more information. These are kind of the high-level goals of the collaboratory. This was launched in London at the British Library. We had a CAS symposium in 2020 at the Alan Turing Institute. And you have baked into our approach is the focus on exploring opportunities and challenges of disruptive technologies for archives and records management. I think a couple of years ago, we actually called that FARM, F-A-R-M, which was the future of archives and records management. And that includes a number of things: digital curation, some of the things Luciana mentioned as potential educational topics in master's programs, machine learning, AI, computer vision, but whatever is the trend of the day and whatever may come next. Our focus is really on multidisciplinary collaborations, which is why I didn't want to do all the talking today, and thought it was important to bring in one of my amazing collaborators who's actually doing some of this work very closely and can share technical results in a much finer way. Our goal is to leverage these kinds of technology developments to unlock hidden information at scale, so in massive stores of records. And of course, if you do that, then there is a kind of a mandate to focus on training current and future generations of information professionals to think computationally and work collaboratively. And promoting ethical information access and use, of course, is inescapable. It's indispensable and part of all of this. These were some of our 2020 founders. You see Vicky Lemieux. It's collaborators at the time from the UK, from Canada, from the US, researchers, archivists, computer scientists, members of the National Archives in the US and the UK. This is a short list. There's over 70 collaborators. I'm really proud and honored that Claudio accepted to join these conversations and efforts. And we've had not enough, but we've had some wonderful exchanges. I was able to sit in on some of Claudio's dissertation defenses and meet some of the students of the University of Brasilia, and where very impressive work in computer science at the intersection of information technology and ethics and societal issues is taking place. And we need more of these collaborations. It's indispensable to continue to make progress. Almost there. So our particular focus in the AI Collaboratory is on something I call LTAR, kind of long-term archival research projects. So we have lots and lots of projects. Everything we do is kind of case study and hands-on, and it becomes an opportunity to bring students in and create opportunities to embed these in classes, interdisciplinary classes and training programs. Here are 5 of these examples or more. And so Rajesh is going to continue in a few minutes, and he's going to take number 2, the number 2 vertical, which is this rubric called Legacy of Slavery, where we've been working with the Maryland State Archives for 7-8 years now. But you see a number of projects here on World War II, Japanese American incarceration, where we've worked with community members for over a decade. Urban renewal, which looks at racial zoning and displacement of minority populations in urban centers. This was done historically in the 30s, 40s, 60s, 70s. So we've had over a decade collaboration with community members looking at archival records. There's an earlier project which has been going on for over 2 decades on redlining, which these were zoning policies from the 1930s under the FDR government in the 30s and 40s. Very impactful stuff. And then our more recent one, which Rajesh and I are collaborating on, is a project called American Responses to the Holocaust, and we're partnering with the Franklin Roosevelt Presidential Library and Museum, looking at some of their amazing collections from the 30s and 40s. And this is with Kirsten Carter, who is a digital archivist and assistant director at the FDR. We're actually so for any of these verticals, there have been AI developments and projects. So if we had more time, we could walk through a number of these. Vertical number 3, we've worked on computer vision projects, also on machine learning, and our latest developments this year are on generative AI and large language models. And Rajesh will talk to you about some of the specifics in that collaboration as well, but with regard to the legacy of slavery, which look at graph databases, knowledge graphs, RAG technology, and other developments. If you're interested in these kinds of things, you can also take a look at that URL, which is cases.umd.edu. So for the last, I would say 6-7 years, we've captured archival content and computational storytelling and experimentation using computational notebooks. So we have a website that highlights Jupyter notebooks and allows you to run computational, to capture computational experiments in the form of algorithms, code, and run those directly in the web or on your local machine, looking at that content. So we developed that specifically to have computational case studies that students can use in classes, and that we can also use to train professionals in the field. So it's very important to capture all that and have a record, and share these kinds of experimentations to facilitate growth in computational thinking at the intersection of archival science. I have a few other references, but there are many, many, many on student projects, working on these at the undergrad level, and also summer classes and what students have come up with in these kinds of contexts using these data sets. So this is I think this speaks to one of the things I heard Luciana say as well. Our goal is really to modernize how archival science is being delivered and is being taught. We have a particular focus on the Master of Library Information Science curricula and graduate courses. And we've actively been preparing LIS students for the last decade, but in particular for the last 5 years, it's really sped up in developing computational thinking skills using innovative technologies with cultural content. On the right, you have kind of various graphics showing student outputs in all these classes. So I'm very pleased to say that with my colleagues, with Rajesh, we have a whole consortium thinking, kind of a think tank. We've been looking at this for a long time. So we've been able to introduce over the last year, a couple of years, 6 new courses at my university in computational thinking and archives, a computational archival science seminar on theory and practices, a hands-on course called Implementing Digital Curation, and then in blue, the last 3 are sort of the very latest ones that we rolled out this year and that we'll be rolling out in the spring of 2026. So I taught in spring with the help of many of my CAS and AI collaboratory colleagues who provided input and feedback and even participated in the courses, mentored students. For the first time, a course in generative AI, large language model analysis for archival collections. It was very successful. I learned a lot as well. I think you have to teach these things many times and work with students and adapt it to an archival audience, obviously. Let's see, do I have that here? I think actually, so there's 2 more, which is one I'm currently teaching this fall, which is using network visualization to explore archival collections. And then in the spring, I'll do a kind of a version of that with spatial representation and analysis. As a matter of fact, I forgot to mention a course I taught in the summer, which had not been done before in my school, which was teaching data science and programming in Python to MLIS students. And I was a little nervous about going there. The students were a little apprehensive, but the overall experience was very positive in the end. And that's another course. I forgot to mention it here. So that gives you kind of a little feel for what we are specifically, practically implementing as we speak, collecting feedback and tuning as we move forward. So I promise I'm done. These are some of the projects we've been working on over the last few years. They're on the teaching education side, on building infrastructure. You heard Clio X yesterday, which is an amazing infrastructure building project. So we've looked at other flavors of that. And then a lot of projects kind of under this space of social justice, human rights, and cultural heritage. And if I take that last category, this is too busy to read on the screen, but it'll be on your slides. This is a little subset, and there's many more of studies, case studies, published work on that relates to artificial intelligence, machine learning, Gen AI, large language models in the context of these various long-term archival research verticals I showed you earlier: legacy of slavery, FDR Presidential Library, Spelman College photo collections, National Archives, World War II, Japanese American relocation, et cetera, et cetera. And the topics are quite broad, from ChatGPT, which you'll hear about next, transfer learning, machine learning, computer vision, NLP, and NER type approaches. So last slide. So we're very pleased to acknowledge the support since 2018, so it's been 7 going on 8 years now, of the Institute Museum Library Services, which has funded a whole series of incremental projects that bring us to this last project. And that's where Rajesh is gonna jump in. So we developed a computational thinking framework in 2018, had a pilot project with 4 iSchools and 5 archives working with specific collections. Just completed a 3-year project on promoting the training of archival and library educators with innovative technology. So we kind of operationalized project number 2, doubled the number of iSchools, added all these professional digital archivists who brought in incredible knowledge and interesting collections, and tried to scale what we were doing earlier. Out of that came this cases website with these Jupyter Notebook reusable virtual interactive lesson plans. So where I'm ending tonight is with a project called Generative AI for Archives. The longer name is Harnessing General AI to Support Exploration and Discovery in Library and Archival Collections. And we also launched an initiative called the Heritage AI Initiative, which hopefully will add other projects like the Legacy of Slavery. So let me stop sharing, and hopefully Rajesh can really bring this home and give you some specifics. I'm not sure where I stopped sharing here. Oh, here it is. Anyway, cool. Sorry for the long introduction, but I hope you find this context useful.
Absolutely. Thanks, Richard. Thanks for this amazing background. So let me try to share my screen. Okay, can you all see my screen?
It's coming. Yeah, now we can see.
You can see? Perfect. All right. So, all right, perfect. Thank you so much, Richard. And my name is Rajesh Kumar Gnanasekharan. Like Richard mentioned, I'm a recent PhD graduate from University of Maryland, and my focus is on working with the technologies in an interdisciplinary space between cultural archives and archivists, historians, genealogists, and also amazing folks like Richard, Wiki, and others as well. So today, what we're going to look at is a project which we worked with Maryland, state of Maryland in the USA. Basically, one of their collections called Legacy of Slavery Collections, and try and see how we could leverage generative AI and like other technologies like knowledge graphs to make the collections accessible and basically enhance access for the community members like researchers or common patrons of the archives and archivists as well. So some background on Maryland State Archives Legacy of Slavery project. So this, why do we have to focus on this? So this has been a multi-year project which started in about 2001 in the state of Maryland by a group of individuals, and currently a person named Christopher Haley is leading this project. And one of the goals of this project was to basically look at all the historical data around the slavery era in Maryland, in the state of Maryland, that the Maryland State Archives has possession over, and use some of that data to discover or uncover stories of several individuals who went through this slave fight and resistance in the state of Maryland during the slavery era. And this was about like a 20-year-long project. And what came out of that project was a large digital database of like records, which had about 16 collections of these data sets, ranging from domestic traffic ads, where the enslaved individuals have been advertised for sale or purchase, from there all the way to like the census records, penitentiary records, and some of the other data set collections include runaway slave ads, and also certificates of freedom, which is like an identity document for the enslaved individuals for them to carry after they have been freed, and also manumission documents, which we'll take a look at in a second. So this is an interesting data set collection because of the like value and the richness of cultural value which is hidden in these collections, and there are umpteen number of stories that can be told and unearthed from these collections. However, even after the multi-year effort of converting the physical records and scan data into digital database, the access to this data has not been as much as we had expected, or the LOS project leaders would have expected. And we tried to enhance this access through several technologies, like using data science and like Richard mentioned, we also created Jupyter notebooks on how to kind of like analyze and explore and clean and visualize the data. And then through pedagogical means as well to create these notebooks, and also as class or lesson plans for the students and researchers to use. We've met some success with that. However, with the introduction of generative AI tools like GPTs, the generative pre-trained transformers, in late 2022, we found that, okay, we could truly leverage this technology and enhance the access to these digitized collections, which would provide more value to the patrons and the community members. So one of the cool things with or the unique things with our project is to basically make the solutions that we develop in an explainable and grounded to the source manner, so that it's not blindly using the generative AI tools we have, like the ChatGPT or the GPT models or the large language models out of the box. Rather, put another layer or a flavor to that, which is going to like provide additional context to these solutions from a cultural manner and an ethical manner as well. So I'll start with some of these examples. Basically, domestic traffic ads, or like I mentioned, these are sort of like the physical ads that have been published by the subscribers in several newspapers during the 1800s era in the state of Maryland. Basically like advertising people, like the enslaved people, for sale or purchase. And here are some examples where they've been listed for sale, and like you could imagine, these individuals have been sold like chattel or property in those days, and these ads speak to that exact language. And after the digital transcription of this into the legacy of slavery database, we had about 2,100 of these data advertisements digitally transcribed. And for our project, we took a sample of about like 1/3 of these data sets to do some explorations and experimentations using the generative AI technologies. And here's an example of a man-emission data set. A man-emission data set is basically, or record is basically something a slave owner would issue to an enslaved individual, declaring that they are freeing the enslaved individual who were under the capacity, along with a witness. And the enslaved individuals who usually carry these records, these are not like official government records, but they usually carry these as an indication or as a precursor to their final proof, which they get by producing this at the county, a county within the state, to get a certificate of a freedom record, which is basically their final identity, like thinking of like driver's license or something, to prove that they are free from the bondage or the slavery. So I also used man-emission record data set and certificates of freedom data set, and there were about 7,200 records for man-emission, about 23,000 records for certificates of freedom for one of my projects. But most of the time we spent on the sample of the domestic traffic ads to kind of like, evolve the solutions that we build. And after we hit a point where, hey, like we're done with exploring this and we need more to explore, then we combined domestic traffic ads, management records, and certificates of freedom data set for cross data set exploration, and like deriving value out of that, which we'll see in a minute. All right, so why generative AI solutions? So like I mentioned, we tried to explore other avenues because that's the core behind CAS. It's not generative AI is new, but we have been doing some of this data science-driven approaches with multidisciplinary collaborators for many years now. And with the generative AI being introduced in late 2022, especially with ChatGPT, where you had like the generative pre-trained transformers sort of providing like access to those models through a conversational chat interface, we took that idea and we said, okay, let's do something similar to the set of collections we have here, and we call it Chat LOS because it's unique. It has its unique flavor because we are not blindly using the GPT models behind the scenes. We are adding another layer through a mechanism which you may have heard through all these presentations, which is the retrieval augmented generation methods, to provide a context-aware response to the end users, but the underlying data set would be one of the data sets that we chose from the legacy of slavery collections. And we were able to demonstrate that we could create an interface where end users can ask natural language questions against these data sets and then get targeted results back from the data set specifically, and not have hallucinations or like context drift that which you usually see by just using the GPT models or large language models out of the box. Even though we saw some of the success with Chat LOS, the initial version using the RAG approach, we did notice that there is the inherent limitation in terms of the context window, where you cannot have all the data set in its memory in one shot and have it kind of like summarize or produce aggregate results off of them. If someone is keen on doing some aggregate analysis, especially archivists and researchers want to do some sort of like time series analysis or whatever, they will be able to do it with the RAG approach because of this inherent limitation and the actual like underlying architecture on how this is set up. So let's look at like how we had set it up, and I really like this image, which is simple to understand on how like we set up the retrieval augmented generation for our project. So there are 4 parts here, and you may have heard about this. Most of you all might have heard about this, but I just wanted to briefly explain it before I jump into the examples. So with the retrieval augmented generation, so you have a database which is basically like a vector embedding or the mathematical representation of your data that you wanted to restrict the chat bot or your solution to add another layer. In our case, it was the domestic traffic ads data set, and each record was considered a chunk, basically. So we took the raw OCR output of each of the ad that I showed earlier, and we extracted that text, and we ran it through an embedding model. In this case, we used the OpenAI's text data embedding model to convert them into a mathematical representation for each record, and we call them each of them as chunks, and we store them in a special or AI-friendly database called the vector database. In this case, we use the Chroma database, and that's one part. And the part to the left, top left, you see is the query. That's the user prompt, the user query, where the user is asking a natural language query through a chatbot or conversational interface, and we convert that question in natural language into embeddings as well, and then pit against the vector database for a similarity or semantic similarity search, and bring back a set of documents that are kind of like considered closely matched based on the incoming query, and use that set of documents and shove that into what's called like a context window, where it also, in addition to the user query and the number of documents matched, we also add a bit of a system instruction saying what is the purpose of this chat interface, and what the actual what the LLM has to look at in terms of providing a response back to the end user, and we kind of provide all of that to the large language model, and the large language model looks at the user query and the system instructions, and in addition to that, the set of documents that it got us matches from the ChromaDB. If there isn't any matches, then it wouldn't have a match at all. So there's also instructions in the system prompt where saying if there are no matches, then the LLM should not make up answers and should simply say, I don't have anything to report back. So this way, we are, in a way, grounding the answers to the source data, which is basically our data set that we have chunked into the vector database, and not lead to hallucinations or the LLM making up responses on its own. So this gives an idea of how we had architected the retrieval augmented generation version. And we also added something called the explainability layer in our chat LOS, where for every response, we also add an user interface or UI element where it explains what the AI did exactly in natural language as a natural language summary. And there is also an option where they can expand and see the internal logs or the basic query and the like AI's interpretation and the number of documents it hit on for the search. And it also shows bubbles all of that up to the user. So this way, if a user is doubtful of the answer, they can expand a certain UI elements for every response to see what actually we did behind the scenes. So it's surfacing all that to kind of like increase transparency and accountability, and also like explaining what the AI did. So here you can see some examples here. I think it's visible to you all, but I'll also talk about this. So what you see on here is there's a user. This is the chat LOS user interface, and it's using like the simple RAG structure of the version. So there is a question here which says, is there a person named Jacob in these ads? If so, list that ad. So this is a typical question where, you know, a researcher or a common pattern who does not know of any of the details in the ad. Maybe they just know of a name that they're probably like a great-great-grandson or granddaughter of a descendant of an enslaved individual. So all they know is just the first name or the full name of the enslaved individual, and they just come to this chatbot and then say, "I'm just curious if you know that if this particular name is in the ads." And this is kind of like, these questions are based off of working with the archivists and, you know, what typical questions that they get from the common patrons who reach out to them and say, hey, can you find this person in your archive? So this kind of simulates that persona or the user scenario. And you can see here, it did find a person named Jacob, and it did bring back the ad. And you could see there's also an explanation layer, which I was talking about, where it says what the AI did. The AI gives a brief summary of what it did. And then if you expand the internal logs, it also shows the exact context that it pulled out from the similarity search. And then it also shows that exact ad, and I have highlighted the areas what the eventual call to LLM actually used a piece of that data to put it in the summary, but that you could see the county, the date, and also the name of the person, in this case, Jacob, in the ad. So it did find one of the ads that referred to a person named Jacob, all by the natural language question that it received, and using the semantic similarity search behind the scenes using the RAG or the vector database. Here's another example for it to understand, we all know like GPTs are trained on billions and billions of internet data, and for a common question like who is George Washington, if you just go to ChatGPT and ask it, it will give you like an essay about him, right? But in this case, it doesn't. It simply says the context does not contain any information because we have limited it to that particular data set, and in that data set, there is no references to George Washington. So you can see that in the internal logs, when you expand it, it also says that it also shows the system instructions on why it should not provide any responses, and why it should limit its response to the context. This is what I was saying earlier, how we added system instructions for it to not waver in its responses and keep it limited to the data set search results. So in this case, it didn't find any hits on George Washington. It simply says, I don't know what you're talking about, and the context does not include any information about George Washington. Here's a screenshot which shows the limitation of the chat LOS using RAG approach, because, like I mentioned earlier, there's this context window limitation where, like it cannot put all of the entire data set in its memory, because the underlying architecture it's actually hitting upon a list of searches or search documents, and we usually limit the number of documents to a certain number. We call it the top K number or something, so where it could be like 5, 10, 25, but we do not know how many how many records are there in the original data set which got chunked. So because of that limitation, when you ask it like how many ads are in this data set, it actually tried to search for that, and in the top K records, if you had only limited it to 4, it brings back 4, and it only provides that as a response, saying there are 4 ads in the context, and these are all the 4 records. However, we know that there are 700 plus records. So this is one of the key limitations of RAG approach. So it's good for doing a targeted semantic search on certain records. However, it's not, what we've noticed, found is that it's not good for like aggregate analysis or trying to do something more with the data set that you have on hand. So that is when we identified another approach, which is using the agent approach. So this is not the agentic AI approach, which is kind of like in vogue right now, but this was done in a year ago when where LangChain libraries had created these agents, which basically allow us to create some individual actionable stuff. So if you noticed, with the RAG approach, it was just looking at chunks and retrieving the results. But with this approach, it looks at the data set in a different perspective, and where you could run a query against the data set as a whole, but it will bring back results by running this query against this data set. So let me show you quickly how it works. So a user will ask it a question like how many advertisements were placed, which is basically like a grouping or an aggregate level question. And it identifies, so the key thing here is that the user is asking questions in a natural language manner, and the chat LOS, which is version 2, using the agent, uses that natural language and converts that behind the scenes into a programmatical query and runs that query against the data set in a full, and then it kind of returns that response back. However, not the exact response which it gets out from the query, but it kind of like frames it into a summary where it puts it back to the users in a natural language manner. So let's look at some of the examples here. So here's an example where the RAG approach was failing when we asked it how many ads were there. It did not, it just came back with saying 4. But in this case, you could see this approach gives us the exact number, like an aggregate of the number of advertisements. And you can see in the explainable layer here, it shows the actual query it ran against the data set and what it did with the data set. It converted that into a Python data frame, and it ran the query against it, and with whatever result it came back, it frames that into a natural language summary and puts it back to the end user in the conversational interface. So here are some other examples where you could do more grouping. So in this case, the question is like, can you create a table of the number of ads placed within each county? So it's now able to group by county and provide a count, and it also gives you the query here. Here's a very interesting example. So this was another typical behavior. So of the patterns, like they would be like, coming here to the to the interface and say, hey, can you find any ads that were placed on a particular holiday within the years of this data set you have, right? And the question is like, were any ads placed on a Christmas day? So in all simple natural language words, right? And how many ads were there? What are the years, right? So you can see there's multiple questions in one question, and there is no defined dates or anything, and the end user doesn't have to like understand what is the underlying data schema or layout or column names or anything like that. And just by giving this question, the Chat LOS version 2 understands what Christmas Day, when Christmas Day falls on, and converts that into a like a date field, and then it also identifies what date to use, and it also filters it, and then it brings back that response, and it also, whatever we get as query set result, it kind of translates that into a plain natural language and says back saying, yes, ads were placed on Christmas Day, there were 5 ads present, and this is the on this particular date. And when you actually go to the data set and filter it, it actually matches that particular thing. So this is cool to see like how it's agnostic of the underlying data schema, and it's very beneficial for patrons and researchers who doesn't have to be tech savvy or anything to do a query on the database, whereas they could just ask natural language questions to get the responses. So like even with the version 2, there was limitations where it couldn't do like a multi data set, or cross data set analysis. So what we came up with was like a knowledge graph RAG framework where we combined the DTA data set, certificates of freedom, and man emissions data set to provide a source of truth context through nodes and relationships, and provide a cross data set analysis, which I'll just go in a minute. I think I'm almost there. I'll maybe take another 2 minutes. So knowledge graphs, as we know, provide structured source of truth context through nodes and relationships. And we built a knowledge graph using Neo4j, and we connected 3 data sets, like I mentioned, and we kind of like augmented our AI setup with the knowledge graph behind the scenes to create GraphQL on the fly based on natural language questions that a user asks. And the graph or the cipher queries are run against the knowledge graph, and the knowledge graph produces results, and those results are being used by the LLM to provide a summary back to the end user. So this is powerful because now the only thing that the setup uses is the knowledge graph. So there's nothing in addition to that. So whatever is in the knowledge graph is what it's going to bring back to the LLM, and the LLM is going to use that. So there's no room for LLM to hallucinate or make up any of this stuff. So it's truly grounded in the source. And what's also cool about this is with the metadata we have provided it can also provide links back to the end user to the original Mail and State Archives database, so they can actually click on that link. It takes them to the actual advertisement, the scanned copy of the advertisement, so they can match against the source to see if the bot provided the right answers or not. So this is a quick setup or like a slide on the Neo4j graph database and what node labels we created. You can see enslaved person, slave owner, and the 3 data sets as a node for each, and then also the relationships at the top, like on how the slave owners and the enslaved persons were connected through these data sets. And below is a simple Neo4j visualization of this or subgraph based on whatever data we had uploaded it. Now, here's a powerful example, which kind of like, goes back to the original, aim or goal of the LOS project, which was to unravel or unearth some of the stories that are hidden in these data sets without a lot of knowledge about the data sets, right? So in this case, an end user asks the question, can you trace the journey of individuals from being listed in domestic traffic ads to receiving a certificate of freedom, including any man emission record? So this is kind of like a traditional chronological path or the life cycle of events that an individual would take. They were enslaved originally, and they have been provided a man emission, and they go and get a certificate of record or freedom record, or they are probably advertised in the domestic traffic ads, and then they were sold or purchased, and then they got a man emission record and then certificate of freedom, right? So when we ask this question with no additional context or no names or anything, all we are doing here is just, can you search against the database to see if there are any individuals? So as you can see, it did find a hit on one of those individuals who went through this life journey where that individual was listed on a domestic trafficker on a particular date. In this case, it's August 15, 1829. And you eventually got an emission record issued in September 1830, and a certificate of freedom followed after that after a month, and then which is in October 25, 1830. So it kind of lists that in a summary, as a summary for any user who doesn't have to understand the underlying data, but in a very natural language way. And it also, with the domestic traffic, as I said, it also has the metadata to the actual hyperlinkable advertisement record, which you can click and take you to the Maryland State Archives database. To the right, you can see the explainable layer, which actually lists the exact query that it ran against the knowledge graph database, and the result it brought back, and what the AI did to summarize that result to send back the answer to the end user. So here is the record, which actually, when you click on that link, it takes you to this particular record, which is a public database that the MSA hosts. So for someone to get here, they have to go through a lot of querying and all of that from the online database. But like with this chat LOS, they could just simply ask a question, it pulls this information, and it just traces it back to the original source. So that's the end of our presentation. And in the future work, we wanted to involve community to get some feedback loops in place, and also flip prompting to ask follow-up questions if they have any open-ended or generic questions. But that's more to come for this project. Thank you so much for listening, and we'll take questions now.
Oh, Rajesh, thank you. Richard, now we have some questions. The first one, can you see the questions?
Yes. Okay. So how can we train data system like an LLM or an AI model to understand archival context and ensure archival qualities? So I'll take this. So basically, what we have been working with is, or the foundation models, like they call it, like the GPTs, or like there's a couple from Anthropic, like Claude and others, right? So, and what we are doing is adding another layer of reference information, like, basically run a search, you bring back certain documents with some prompt instructions, you pass that to LLM, you're trying to limit the LLM with the foundation model based off of this information. But an ideal way would be to, which we have also dealt with through the traditional machine learning setup, where you kind of like have some of these labeled data sets, and then working with the archivists or historians, you have certain data set and you label them to go through the supervised learning approach. Or these the foundation models themselves can also be fine-tuned by adding additional set of data set you have, right? So you don't have to go through the painful process of creating a supervised learning, training, all of that, but by fine-tuning it, we have seen some of that to be successful. However, what we have also found is that none of them have been like closer to using a RAG approach with the foundation model. So we found them to be more successful than fine-tuning the original data. But again, there are several techniques you could add, like there's also layers like LoRa, QLoRa, or something like a ranking model and all of that to experiment and find out what is the best fit. But in an archival context, definitely working with the archivists and the basically the custodians of the data, because they know better, and to trying to come up with some metadata and like through a supervised learning approach or your fine-tuning approach. Those are the two approaches that comes to my mind at the moment.
Okay. The next one.
This one is for you, Richard. Oh, you're on mute.
Sorry. Thank you for this question, Amelia. Yeah, so CAS is concerned with computational methodologies to optimize archival processing in steps. So there is sorry, there's a little background noise here.
Yeah.
Not at my end, though. it's coming from somewhere else. Yes, that would be really interesting. I haven't had a chance to play with Paradata in that context, but your suggestion is, I think, has a lot of potential. There's a project that comes to mind if you're interested in that. This is before Paradata was coined as such. One of the very inspirational projects is the ERI project out of the European community. It's EHRI, European Holocaust Research Institute, out of King's College and University of Amsterdam. I think they were just awarded they became a permanent European research center. They were the very first folks, and some of the work we're looking at really owes that project these original ideas. They're the ones who pioneered that, but they looked at graph databases, which is kind of a precursor of what Rajesh talked about today in the form of knowledge graphs, which is a flavor of graph databases. But they came up with a knowledge graph model that not only captures attributes and properties of digital records, but also tries to capture these kinds of interpretive traces you mentioned. And I think in their model, they came up with a portal where you could interact with the datafied, digitized resources. And they also recorded how users interacted with archival objects and records. So it's kind of a multi-purpose model where you have flavors of Paradata beyond the actual metadata that describes and they integrate all of that into one large sort of Uber graph. And then your graph becomes this form of knowledge base that then you can interpret, query, visualize, analyze. And at that point, that allows you to incorporate interpretive traces beyond records metadata and the kinds of things you suggest.
Thank you.
Will the slides be made available to?
Yep. Yeah, absolutely. We can send it through Claudio.
Okay. Thank you. More questions or no more questions? I think that
no more questions. No more questions.
So thank you again,
Obrigado.
Dr. Rajesh, Professor
Absolutely.
Richard. Thank you.